Hello, I'm Colin Deeter, and I'm joined by Madison, Messmer, and Marley Persch. Our senior design project is Bioplastics, an exploration of sustainable alternatives. SKF was the sponsor of this project, and they came to us with the goal of finding a sustainable alternative material for their current nylon 6/6 25% glass filled that is used in their bearing cages. During this project, we examined two potential alternative materials. The first is a 30% glass-filled polypropylene, and this was to reduce the amount of carbon emissions produced during the processing of the material, which is injection molding. The second material is a bio-based nylon 410 30% glass-filled. This was to reduce the amount of carbon emissions produced during the synthesis of the material. These alternative materials will be compared to the baseline nylon 6/6 on both material properties and carbon emissions to see if they would be suitable for the bearing cage application. The work over the past three semesters of this project consisted as follows. We began with extensive research to find potential alternatives, conducted material tests on all the materials, performed life cycle analysis to gather emissions data, and came to a final conclusion on an alternative.
We also completed mostly all the testing necessary in-house in the plastics lab. This was done in order to compare to the baseline material of nylon 6/6, but also to be used in the LCA calculations. It can also be seen that in all the figures, nylon 6/6 is orange, polypropylene is blue, and nylon 410 is purple. Looking at the graphs in the middle, you can see the sensitivity analysis done with the LCA software. Sensitivity analysis shows how specific material properties have an effect on the carbon emissions. It should also be noted that nylon 410 did have a different database, and that should be taken into account.
The graph in the top right corner of the poster shows different impact categories for all three materials in comparison to the global warming impact category. This data is important since sustainability should not just be focused on global warming impact, but also other areas such as water consumption and land use. As can be seen in the graph, while nylon 410 has a lower global warming potential than the nylon 6/6, it has significantly higher impacts on water consumption, land use, and marine eutrophication. These are things to keep in mind when making sustainable material replacement decisions. The graph right below shows the overall carbon emissions values for the three materials sectioned into synthesis, compounding, and injection molding steps. Polypropylene had the lowest carbon emissions value of the three, with 10.91 kilograms of CO2 released per kilogram of polypropylene produced. We have theorized that this is likely due to the high process optimization levels in the well-established polypropylene industry in comparison to the newer bio-based material industries. Overall, our final recommendation for SKF's polymer bearing cages would be to replace their glass-filled nylon 6/6 with a glass-filled polypropylene material. This replacement would have to happen on a case-by-case basis since the polypropylene material has slightly lower thermal and mechanical properties. Thank you for listening.